Hello. Let me know if you guys can hear me. Is anybody out there? Cool. All right, so let's get to it. All right, just like the last time where I had started talking about uh, some functions and talking about some advanced, you know, concepts of, uh, you know, applying, you know, or creating higher order functions to make certain things easier. We're going to continue again. Basically, throughout the rest of the session, I'm going to constantly start off maybe like the first, 20, 30 minutes, just talking about advanced features of JavaScript, or just things that you may not know, or things that I did not go over because of, time constraints or whatever, the first week of the, JavaScript stuff. Cool. So today we're going to do some more higher order functions. So we have Gautam saying hello, hello, Martin, hello. Cool. So hopefully you guys are all ready to get your minds blown again. So before we start, let's recap kind of like what we did on Monday. So I'm just trying to remember off the top of my head what we did. And I had, let's see, we had created just a basic function. Created a function. I forgot what we called it. Oh yes, it was called is greater than, and then you would pass in, some value. That was the idea, and then this function would return, because as I said before, that functions in JavaScript are first-class citizens. That is, that we can pass functions around into other functions. We can pass them at, we can assign functions into a variable. If we couldn't assign a function to a variable, then you cannot pass it to another function. So because we can assign a function into a variable, that means that we can pass them around. That is, they are first-class citizens. So an example of first-class citizen is like your numbers, 1 through whatever, or whatever numbers there are. Strings, they're first-class citizens. You can pass them anywhere, assign them to variables, etc., etc. So functions are also first-class citizens. Languages like Java, I don't believe have that ability. You still need to use an interface in order to use, arrow expressions. I could be wrong. In C#, functions are also first-class citizens. You can use a delegate in order to do that. So it's pretty cool. Okay, and in C++, yeah, I guess you could also say that functions are also first-class citizens because you can pass a pointer. Yeah, it's a little more complicated, but you can totally do it. All right. So to recap, we have a function called is greater than, and the idea behind this type of pattern is to basically abstract away some of the details. When I had written the functions before, it was too much code repetition. So here, let's abstract some of the details. So I want to return a function, okay? This is called an anonymous function because I'm not going to give it a name. And then this function takes in a parameter. We'll call it number. And our goal here is that we just want to return a Boolean value, true or false, if the number is greater than this particular value. So all I'm going to do is say return number greater than value. Okay? And that's it. So this function, you give it some value that we're going to compare against. You then return a function that takes in another number, and that's the number in question. We want to basically freeze this value, so to say, so that we can reuse it again and again. But this value here that's in the second function is the one that's going to be changing all the time. We want to freeze this one. But the idea is we don't want to have to implement this same logic again and again and again. Now, this is a very trivial example, right? But you can imagine what you can do with this pattern, okay? So let's give it a whirl. So we have a function that creates functions, okay? So now I can assign the function that gets created by is greater than to a variable. So I'll call it, I'll use const, because that's a pretty good way of saying that, hey, we shouldn't change this variable like ever, right? Assign it once and we're done. So I'll call this is greater than, and then, at this point, name it something very specific, but that's meaningful to this, greater than what? And let's say there's a particular value, like a threshold that you always want to check against, but you might want to check against something else in another part of your code, so you don't want to have to repeat yourself. So that's why we're writing this abstraction. So we'll say, let's check to see if a number is greater than 10. Okay, so is greater than 10. Okay, beautiful. We then use this function to create the function that has that logic. So is greater than what? Well, is greater than 10. There we go. So now if we hover over here, is greater than is a function. As you can see, this is the syntax for a function that takes in a number and just returns a Boolean. And the logic is in the second function. It's abstracted away from us. So notice I'm not writing any other logic here. I'm just creating it. I'm using this function to create a function, and this is the name that describes what that function that is being created is going to do. It's just going to check is greater than something. So now I can say console.log is greater than 10 and pass it a number. Let's say 100. Okay, so I can run this node. And that's true, 100 is definitely greater than 10. So let's type in 0. Is 0 greater than 10? No, that's false. So to prove to you that is greater than is in fact just this implementation with this value basically frozen with this value right here, 10. All we have to do is you can take any function in JavaScript and just toString it. Okay, when we do that, look at that. This is greater than 10 just has this function. The function is number, return number greater than value. Now this value, however, is in fact 10 because we passed it right there. Now a lot of these details, again, is abstracted away. You can't really see it, but this right here is responsible for that. Okay. Now we're going to show more advanced examples right now. Okay. Now, before we get started on that, I just want to show you this is a way of doing it. Okay, this is a way. But in ES6 introduced something called an arrow function. Okay. And so, that's something that you probably want to use more often than not, usually when you want to get rid of the this keyword. So the way you do that, to convert an ES5 to an ES6 function, we just say const. You give this is greater than becomes the variable name. This is the identifier. We then set it equal to, and then we use this equal sign, and then the right chevron, and you have this arrow. Okay, that's it. These are equivalent. So when I run this, so let me remove this toString. Let me put in some value. Let's say, I don't know, 5. Is 5 is greater than 10? So is 5 greater than 10? That's false. Okay, so it's still working. So I can also replace this. So I can replace this function. So I just remove that. And all I have to do is add this arrow right there. Boom. Look how clean that looks. Less typing. Less typing. So I can run this now. I get the same response. What's the advantage of using the arrow function instead? So that's a very good question, Jim. The difference is that I cannot instantiate this. I cannot say something like new is greater than 10. Okay, that might look weird to you, but we're not able to do that. Is greater than is not a constructor. Okay, you might thinking, why would you ever say new a function? That sounds dumb. Well, Jim, I will say yes, that looks weird, especially if you're coming from another language. However, in JavaScript, that's how you create objects. So I can create a function here called person that takes in, I don't know, say a name. And then this is going to be weird. I can say something like this.name equals name. You're like, hold up, we're in a function. Where's this coming from? And to that I say, yes, this confused me too. However, with this function here, I can basically create a class. I can create an object. I can say const. I'll call it, say me equals new person, and I'll put my name in here, Kevin. Now I can say console.log me. So I'll remove this console so we don't see it. Okay, and let's run this. And look at that. It's an object. It's a person object, and that's the data. It's a JavaScript object. And I use the new keyword on a function. Kaboom! Right? That's weird. Because functions are objects. I know, it's weird. That's one of the really weird things with JavaScript. However, when you use an arrow function, you're basically saying, no, do not use the new keyword on this. It doesn't make sense. Because if I have a function, there's no stopping you from using the keyword this. But what does it do? It's undefined behavior. With ES6, though, I feel like they're kind of backtracking on certain things. Because ES6 introduced classes. They're kind of saying you should probably use classes instead of functions, but we understand if you still use the functions for backwards compatibility. And there might be some advantages to functions. You know, there's an argument to be made there too. But when we're talking about functions, it's kind of like standard to use this now. However, we do revert to the function version of defining a function this way when we want to be able to hoist functions. That is to say, if I want to be able to, let's say I have a function called say hi. Hi. Okay. I don't care where that function is in the file. It can be way down there. I don't care. I want to be able to say hi. So I want to be able to call it before it's even been declared. Now, the reason why this works is by an effect of how the JavaScript language gets compiled by the browser. When you say hi, this file has already been scanned through the compiler, and these functions are in memory. Functions in JavaScript are in memory. So by the time you say hi, it already knows what you're talking about. It remembers. There's like a lookup table. So it knows what you're talking about. So you don't need to define or declare your function before you use it. The only time that this doesn't work, this effect that we call hoisting, is when you assign a function to a variable. Then it does not get hoisted. So if I were to say change this by saying var say hi is equal to, and I just remove that. Okay, if I assign it to a function, to a variable, it's going to say hi is not a function. So the only time it doesn't get hoisted is when you assign it to a variable, because then it doesn't get hoisted. Okay. The say hi does get hoisted, but what it's assigned to does not, right? If we were to go up here and then say console.log say hi, we want to see, okay, what the heck is this? You're going to see that it's actually undefined. It's undefined. It didn't crash. It's just undefined when we try to log it. It's undefined. So we're trying to execute something that is undefined. You're trying to execute it like a function. That's what's going to cause a problem. So the variable got hoisted, but what it was assigned to did not. And the function's there. So as a result, you basically prevented your function from getting hoisted. So you can do stuff like that. So hopefully that makes sense. What the difference is. Now, why do we use the arrow function instead? Okay, it's just to prevent some weird, artifacts like that. There's other reasons too, but that's probably one of the main ones. It's because we want a function that basically doesn't keep a state itself. We don't want to have the word this in there. One of the side effects of the old way of doing things was you could use the keyword this, and it made a lot of code wrong. A lot of people were using it incorrectly. So this new arrow function kind of like, one, it looks cleaner, you're typing less, but also it gets rid of the keyword this. So it makes you as a JavaScript developer less likely to make a mistake. Okay, cool. So we have that now. All right. Cool. So again, we have this, create a const here. Let's create an array. I'm going to call this movies. Okay. This movies is going to be an array that has objects in there that define what a movie is. So we'll call it title. So as if anybody has any favorite movies, if you know the genre, the year, and the title, put that in the comments and I'll add it to my little data. I'm going to pull some out of my head, but if you guys have any to participate, shoot some of your favorite movies. I'm going to start off with Star Wars, of course, classic. So Star Wars, okay, genre, sci-fi. The year this one came out, I forget, was it 1976 or 1977, something like that. Okay. We have a Frozen fan, so Frozen. And the movie's called Frozen. Genre, animation, beautiful. The year, 2013. Okay. Let's see anybody else? Swanden? What's that? Let me know the genre and the year and I'll put it in there. Space Jam? Oh yeah, Space Jam. How can you forget about Space Jam? Take me to the Space Jam. Alright, Space Jam, genre, what is that? Comedy? Yeah, I could see it being comedy. Yeah, comedy. Okay, year. We have 1996. My goodness, I'm old. Okay. Hangover. Oh yeah, Hangover. The title. Hangover. Genre. And yes, this one is in fact a comedy. And that was 2009. Beautiful. Okay. So let's add some extra ones. We'll do Star Trek. I remember when this came out. Genre. This is under sci-fi. As you can tell, I'm a sci-fi kind of guy. This came out in 2009 and also, I believe. Yeah. Let's see. Anybody else? Came out, yeah, I know. 19. Oh, jeez, dude. I still remember seeing that movie in theaters. So, as you can see, my age is kind of showing. Oh, Matrix, yeah. I still remember watching Toy Story 2 in theaters with my family. That was such an epic movie to see as a kid at the theaters. Epic times. All right, so here's our movie list. Okay, cool. Now, hopefully, when I show you these, these kinds of examples, I really hope that you guys are doing your due diligence and then trying these things out on your own time, making it more complicated, or try to see in your daily life as you're using other apps, whether it's a website or an app on your phone, blah 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 blah. I want you to see how the things that I'm showing you are being used in software in your everyday life. Okay? So what I'm going to show you right now is something that if you were to get hired at a company and you were playing around with data and you wanted to show it to a user, then what I'm about to show you is a basic task that would be asked of you if you were working at, say, let's say Netflix, and you had movies, and you're like, okay, on the website or the app, whatever, oh, we want to see the movies that are comedies or something like that, or hey, let's show them the movies filtered by the year, so like, or not filtered by, let's say sorted by the year, let's say, okay, or sorted by genre. Okay, those are valid things, right? Or is that not a valid thing to want to do in an application, right? You want to sort some data. Now, I'm not going to show you how to sort a number, an array of numbers, an array of strings. That's, okay, let's be fair, that's bullshit, right? You're not going to be doing that. And you can look that up on the internet, that's easy. But how do you sort this? We have a complex object here. How do you sort this? Well, I'm going to show you. This is more grounded in reality. All right. Well, we've been talking right now about higher order functions, okay? In JavaScript, some of the methods that are attached to array types are higher order functions. So today we're going to talk about one, and that's sort. So I don't know if you've noticed, but whenever you create an array, in this case I created my array and I called it movies, you know it's an array because it has these square brackets. If I interrogate it using the dot operator, I have a bunch of different methods here, right? We've seen push before already. But there's an interesting one. There is a sort one right here. So let's take a look at this guy right here. So you can already see that this is kind of weird. It looks kind of funky. It's like, okay, what are we sorting? So this right here, array blah 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 blah, is our data. Dot sort, looks like we have to pass something called a compare function, and the question mark there just means that you don't have to pass anything. Okay, so I'm just gonna go call it like this, and then you should probably do your due diligence and you should read, right? Get used to reading documentation. So here I'm reading here. Okay, so sort. Function used to determine the order of the elements. It is expected to return a negative value if the first argument is less than the second argument. 0 if they're equal, and positive value otherwise. If omitted, the elements are sorted in ascending ASCII character order. Interesting. So here shows you an example of an array, and you're calling sort, and you can pass it a function. Do you remember the definition of a higher order function from Monday? A higher order function must follow one of two things. One, the higher order function accepts as input another function. So by definition, this sort accepts a function, so it is a higher order function. The other part of the definition, or one of the bullet points to know if your function is a higher order function, is if your function returns a function, then it makes it higher order. You don't have to do both at the same time. You just have to satisfy one of those conditions. Your function accepts another function, or your function returns another function. Then it's a higher order function. So this sort is a higher order function because it accepts a function. So hopefully that's ingrained into your head. Okay, cool. All right. Cool, so I'm just gonna call sort, and the sort sorts the array, what we say, in place. That is, this data here, this array here, gets mutated. So it doesn't return a brand new version of the array. It just sorts it from here. So I'm going to call sort, and I'm not going to specify anything. I just want to see what happens. So what happens? So I call sort. Now I'm just going to log console.log movies. And let's just see what it does, right? Let's see what the undefined behavior is. Okay, so let's say node, oh, okay, well, it didn't crash. And if you look at the data, so Star Wars came first, then Frozen, then Space Jam, then Hangover, then Star Trek. Okay, so nothing happened. So nothing happened. Okay. Cool. So let's apply it a function. Now this function takes two arguments, A and B, and we're basically going to compare these two things. Okay, so I'm gonna pass in A, I'm gonna pass in B. Okay, I'm gonna use my arrow function, the thing we just learned today. Now this function should return a number. Now the numbers that it returns are three possibilities. Okay, so let's start with the first one. So let's say you were tasked to sort the results of the movies that you got by genre. So we should have animation followed by comedy, and then sci-fi. Okay, that's sorting this data by genre. Okay, let's do that. So to do that, we need to make sure that whatever genre is, this A, if the genre in alphabetical order from A comes before B, we need to do something. So we say if A dot genre is less than B dot genre, that is, it comes before. We're comparing strings here. Remember, genre is a string, so this is valid. So if I want to know if a string comes before another string, we can use this comparator operator like that. So if A dot genre comes before B dot genre, so we say return -1. So if A comes before B, you return -1. Okay. If A dot genre is greater than B, meaning A dot genre comes after B dot genre, then we return 1. Those are only two options, right? Well, we have a third option, which is otherwise they must be equal, so we return 0. Okay. Did I lose anybody there? Does everybody understand what this is doing? We're just trying to compare two movies, and we're comparing the genres. Trying to see, okay, does A come before B? We return a number. Does A come after B? We return a different number. Okay. Since those are our two options, either you come before, you come after, the only other option is, well, you're the same. So what value is that? Well, we use 0. 0 means they're exactly the same. Okay, so I'm going to bring that up so we can see. Run this. There we go. So now we have our movies sorted by genre. So Frozen comes first because it's animation. Then we have Space Jam and Hangover because they're both comedies. And then we have Star Wars and Star Trek because they're sci-fi. Bada bing, bada boom. Is this similar to comparing Java? Yes. Yes. So we have somebody here that codes in Java quite a bit. And the answer is yes. Exactly. So I like how you said it's similar to comparing Java. And yes, because this thing that we supplied is called a comparator, right? It's a comparator, which is a type of what we say more abstractly is a predicate. It's a predicate. That is, you take some input and you return a Boolean. So for those of you guys that paid attention in discrete mathematics, you know what a predicate is. In fact, you should know the rules to predicates, right? This is all just discrete math. So whenever you're wondering like, oh, what the heck was I doing in discrete math and blah 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 blah. Well, now you know. You prepared yourself just to learn these basic things. It's basically just Boolean stuff. Like you taking I don't know. Let me find a good. Yeah. A predicate is an expression of one or more variables. So how many did we have? We had two. Okay. We can sometimes refer to these variables in mathematics as the subject when we're talking about predicates. That's also what some people call it. Defined on some specific domain. Okay, let's talk about what they're saying here. On some specific domain. Now, in mathematics, we would say, okay, we want to say that, you know, some predicate P, we're going to try to do a logical comparison, something, but the elements that we're using, we need to scope it. It needs to be in something. Sometimes we call this the universal set, so meaning it could be anything. Or we say it's in the set of numbers, or like real numbers or integers or natural numbers. Or it's the set of A intersect B, or some, you come up with whatever you want, right? At the end of the day, it's just a set, your domain, right? So that domain is our set. So what's our domain here? What is A and B? What's our domain? It's these objects. This is our domain. Our domain is an object that contains the properties title, genre, and year. So when you're in discrete mathematics and you probably thought to yourself, I'll never use this again. Well, we're using it right now because it's just logic. That's it, right? So hopefully this now makes a lot more sense, what you were doing in discrete math. So then it continues saying, a predicate with variables can be made a proposition by either assigning a value to the variable or by quantifying the variable. That means we set it to something. So the following are some examples of some predicates. So let E, some function, call it E, pass in some variables, x and y, whatever, denotes x equals y. Okay, we just want to see, does x equal y? Is that true? Okay, is that not similar to what we have here? We're comparing two things. We're using a comparator. Is it less than? Is it greater than? In this case, well, there must be equal. That's like the default value. Okay, well, we're kind of doing the same thing. However, predicates don't return numbers. You don't get numbers. You have truthy values. So truthy is something that is assumed to be true, right? That's kind of like what truthy means. And falsy is something to be false. Now, the reason why we say truthy and falsy, not just true and false, is because there are some symbols that we can use in replacement of something that we consider to be quote-unquote truthy and quote-unquote falsy. So these predicates that we supply to sort and the likes, any kind of higher order function that takes in a predicate or a comparator and it returns number, usually they always say feed it a predicate such that the return value can be coerced or turned into a Boolean expression. In JavaScript, you can turn 0 to false and -1 to false. And then anything above, well, I should say this. Anything from 0 and below, like the negative numbers, can be coerced into the Boolean value false. Anything greater than 0 can be coerced into true. So I could return -1 billion. I can return 1 trillion. You know, I still have to return 0 here. And we're good. And we're good. That's the only requirement. Just make sure you return a value that can be coerced into a Boolean expression. Negative numbers from 0 to negative numbers go to false. Anything above 0 becomes true. So this, although it looks like we're returning numbers, the sort function internally will take those numbers. It's kind of expecting that you return numbers, and it will coerce it to booleans. If you return a boolean, it's just going to accept those boolean values. Okay? Hopefully that makes sense. Okay? And so if you want to like read more about predicates, you can look here. Like honestly, just crack open your discrete math book and just read what predicates are and the kind of things that you can do with them. Because that's basically what we're doing here. We're actually applying the stuff that you learned in discrete math, applying it here. You just don't know it. Okay. So that's cool. So the next thing would be like your boss says, "Hey, great job on this task. You did fantastic. Here's the problem. I noticed that Space Jam and comedy and like whatever, whenever they have the same genre, they're not in order. So then your boss says, "Hey, is it possible that you can sort this by genre? And then if they're in the same genre, sort that genre by the title. Can you do that? Thanks." And you're like, "Yeah, of course I can do that." So how do we modify this to do that? Well, we basically need to compare 2 times, right? We basically need to compare 2 times. So your first thought might be, okay, so we sort it by genre and then we sort it by name. No, 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 no. You have to sort them at the same time. At the point of comparison, we must do the comparison together. Okay, not at the same time, but in a possible sequence. So how do we solve this problem? Well, we can start by doing the following. Let's take this predicate and extract it out and make it its own function. We'll call it const sort by, or sort movie by genre, or movies. What's a better word? Yeah, sort movies by genre. Okay, equals yeah, we takes an A and a B. Actually, I can just paste, right? There, done. Beautiful. All right. So now I can just feed this directly here, sort movies by genre. And we can run this again, and we get the same result. Beautiful. Okay, but now your boss says, "I need you to also sort it by name." Okay, well, let's create the logic for that. And hopefully, as I'm writing this, you see a problem. Const sort movies by, what is it, title? Title equals A, comma, B. Okay, well, if A dot title comes before B dot title, we should return -1. Okay, if A dot title comes after B dot title, we're going to return 1. Else, they must be the same, so we return 0. Does that make sense? You guys follow this? Is this okay? Yeah, let me move this out of the way real quick. Does this make sense? Is this okay, what I just did here? Okay. Let me know if you guys are confused or have some questions. I'm just creating another function that now sorts by a different criteria. Okay, that's all I've done. Yes, sorting is very cool. Okay. Okay, cool. So I'm just gonna clear this up real quick. All right, so let's test it out. So I'm gonna say sort movies by title. Okay, so I'm gonna run this. And so now we have Frozen, Hangover, Space Jam, Star Trek, Star Wars. And now the genre, it looks like it's sorted by genre as well. It just happens to be that. Okay, but that's not the case, okay? Let's add another movie here just to make sure that this thing is working. So what's another movie that we can add? That's also a something else. So let's do let's say an action movie. Or a movie that's suspense. A movie that's suspense. Law abiding Citizen. I don't know if you guys have seen that. That's a really good movie. Got Jamie Foxx. This one I would say is like suspense or thriller. I think it's a thriller. Well, no, I want to use suspense. I need something with an S. So suspense. I think this one also came out in 2009. Yeah, somewhere around there. All right, let's run this again and see what happens. Okay. So clearly, I just want to show you because it just happened to be that genre looked like it was sorted, but I just want to make sure that you guys know that it's not. So there, boom, suspense kills it. All right. Inception. Yeah, that's a good one too. Let's go with that one. Got Leonardo DiCaprio. Title. Inception. Genre. And that was, and what is this? Is that a thriller too? Is that suspense? What is this? I don't know the genre of this. Drama? No, it's not drama. We'll just say it's its own thing. It's Inception. Genre. That's the genre. When did this movie come out? 2010? Or 2009? Was it 2009 or something? Oh man. Can't keep track of time anymore. Alright, so let's say the genre is also Inception. Sci-fi action. Alright, well that's a good one. We'll just use action. That's action and 2010. Okay. Oh, that's too much. Okay. Cool. Now we have action here and then suspense there, whatever. And so it's out of order. But it's ordered by title. Beautiful. So this is working. Now hopefully you see a problem here or you see something. Remember we talked about this principle called dry? That is, do or don't repeat yourself. Okay, we're going to solve this problem. But first, let's solve the problem of sorting. So we need to come up with a way to sort both of them. Okay, because what's happening here is that, okay, when we sort it by genre, there are some genres that are that repeat. So we need a tiebreaker, right? Because when they're the same, what happens when they're the same genre? They just return 0. Okay. And we remember that gets coerced to a Boolean value, which becomes false. So how can we use that to our advantage? Okay, well then let's create a function here, a, b, so our comparator, a, b. So let's create the body here. And what we're going to do is we're going to return, I'm going to do this one step at a time. So I'm going to say sort movies by title. I'm going to pass it A and B. So I'm actually going to execute it here. So before I just passed it, now I'm going about, I'm doing this a roundabout way. I'm actually going to just execute it. So I'm going to say return sort movies by title, and I'm executing by passing A and B. And this returns a number. You can see right here, it even tells you, it looks like it's returning 1, -1, or a 0. Okay, so if I run this now, we get the same thing. Okay, nothing's changed. We're wrapping the call in another function. Okay. Now, the idea, first of all, was we wanted to sort it by genre. So let's change this. So sort by genre. Okay, let's do that. Okay, now we have action, comedy, or action, animation, comedy, sci-fi, sci-fi. And these sci-fis, they're not in order. Comedies are not in order. So we got to fix that. So what we can do is, when these two are the same, we need to have a tiebreaker. So what's going to be the tiebreaker? The next thing you want to order it as. So the way we can do that is we just use the OR operator. So the double bar means OR. So we want to sort by genre. But if they happen to be the same, then the tiebreaker is sort them by title, past A and B. So if they are the same, sort them by title. So now when we run this, you'll see that they are still ordered by genre, and then the comedies, since they're the same, they're now going to be ordered by title. Sci-fi, sci-fi, ordered by title. And then this one's just by itself. You guys see that? Hopefully you guys saw that. Okay. Cool. Again, we're going to talk more about this. Hopefully this has been a good exercise for you guys. To look at how you can sort things using higher order functions. Okay. All right. So let's come back to React. I'm going to start this off. All right. So in the last, on Monday, when we were talking about React, I talked about props. Okay. And that's a way that we can send data over to a component. So we can do whatever, and then we can reuse it as many times as we want. Because basically, this is a function. You're basically just calling a function. But you're calling it in a really funky way. The syntax is a little different now. Okay. So here I can say hi or whatever. Just like that. Okay. This thing is still compiling. Okay. Cool beans. All right. So what I would like to do now is I want to talk to you now about something called state. Okay. So before we do that, let's take a look at some more props. Okay. Some more props. This is uses in spaces. I use tabs. There we go. Okay, cool. So let's say, in this function called app, we had some data here. So we'll say, const. I don't know if you guys can see it saying hi right there. Let's see, can I move this like that? Okay, we go. So a const, we can say here message. And here I'm gonna say this is hi. Something like that. Okay. Now I want to be able to pass this message to greetings so it can pop up here. Now how do I do that? Well, can I just say message here? No, you can see it's turning red. If I try and run this, it's like failed to compile. It's broken. Okay. So how do I fix this? How do I do this correctly? You have to wrap it in curly braces. Remember, we are in the JSX world. When we enter in any of this kind of syntax, you're in the JSX world. That's the JavaScript XML like syntax, okay? So in order to go into the JavaScript world, we have to use these curly braces. Let me make this a little bigger so you guys can see. And once I do that, I save. Now it says hi world. I can change this to say hello world. Hit save. Boom, now it says hello world. Okay. Now, I told you that greetings can take in props. Okay. But remember, app is also a component. Index.js is where we begin, right? This is our entry point into our entire React application. That's index.js. And here's my component. I can pass it something too. I'm gonna call this data, and I'll pass it something. Let's say welcome to React. Okay, hit save. Now in app.js, I just need to extract it. So I have props now, so I'm gonna say props. There we go. And in this props, I pass the this message here as a property of data. So now instead of using this, I can just say, well, I can do one of two things. First, I'm gonna do it here. So I'm gonna say props dot message, or was it data? Data. I'm going to stick that into message, and then message is going to go into greetings. Okay, let's refresh this. Now it says welcome to React. So here I can change this to anything I want. So you can see the levels of passing data. I define the data in index.js. Welcome to React. I then pass that to my component app in this props object. I then extracted the data part, put it in a variable called message. I then pass this into this other component, and it's expecting it to be called message. And then it grabs it, props, and then it uses the curly braces here again to go into the JavaScript world. And I just say props.message, and it displays it. Okay. Now, props is the standard way. Again, you can call this whatever you want. It doesn't matter what you call it. It's the fact that the only thing that's going to get passed into your component is this, and it's just going to be a JS object. So if I go back to app here, if I say console.log, let's log what props looks like. Okay, if I hit save, and I go to inspect, go to the console, it's just an object. When I expand this object, it's an object. So app has props, which is an object, just a regular JavaScript object. And one of the properties is called data, which is not a surprise because that's what we called it here. If I change it here to something else, let's say I call it tuna, hit save, refresh this. Now it says tuna. Okay. However, when we grab the message here, that's why you don't see anything over here. That's why you don't see anything here. We're expecting the prop to be called data, but now we changed it to tuna, so now we have to change it here, tuna. Hit save. Now we say it here, welcome to React. Okay. Same thing with greetings. We've got greetings, console.log. Let's look at props. Just going to log the props, hit save. There you go. We get message. Greetings is saying message. It's saying it has message, and the message it says welcome to React. Do you see how this is working? These are just functions. This is a function. I'm passing it a parameter as a property tuna with this value, and then app is grabbing it. There's tuna, and then it's in a roundabout way. It's putting it in here and then sending it over. And now greetings is a function with a variable called message, and it's sending it over here, and then it's using it here. Okay. That's all it is to React props. That's really it. It's nothing more than that. Now again, what I could have done too is instead of grabbing it like that, props.tuna, I could have just put it directly in here. That's totally possible. Props.tuna. Okay, same thing. No problem there. Okay. So I'm just going to remove this because I don't need that. Okay. So now what I would like to do is I want to create a component called movie.jsx. Okay. So we're going to create a component. Now this component, sole responsibility is to get a movie and then it's just going to display it. That's all it's going to do. So let's do that. So we're going to say import everything as React from React. That's line number 1. Then we're just going to create a function. Function, movie. And we will be expecting some properties to be sent to us, some data. Okay. We then want to return something. We're going to draw something to the screen. So we're going to say return. I like to use the syntax of using a parentheses like this to keep, to make it look nicer. So I do it like this, and then I say, okay, let's say a div for now, and let's just do nothing, okay? We now need to export. Remember, your components need to be exported. Once you're in this world, If you want those functions or whatever to be used outside of this file, we have to say export default and then movie, which is the component name. Okay. So right now, what I'm going to do, I'm going to say console.log. I'm going to just say movie, like that. And then I'm just going to add the props there so we can see what this movie component got. Okay. And so now in my app, I want to use it. So I'm going to get rid of greetings. Don't need that anymore. Get rid of greetings. So I'm going to say import movie, right there. Movie from / components, because remember the / meaning in our current, where this current file resides, which is in the source folder. You can see it's right here. / go into the components folder and then get the movie. There it is, right there. Boom. That's how we import things. Cool. All right, I'm going to remove the props from app. We don't need that. Okay, cool. Okay, now that we have that, I am going to say, let's say by some process, doesn't matter how, but some process, we got movies. Let's say an API from a backend. We got the data, movies. Now we want to display those movies to the user. Okay, how do we do that? Using the components. Okay, well, let's do it. Let's say we have just the one movie. Just the one movie. It's an object. So let's say we just had one movie. So before we had title, Star Wars. Genre was sci-fi. And then the year, again, I believe it's 1976. I could be wrong. It's 1970, or maybe it's 1977. I think it's 1977. Okay, cool. So I would like to do this. This is what I would like. I would like to just say movie component, and then I would like to just pass in movie and pass the data, movie, like that. So I want to pass to my movie component a property called movie, and the data is here. It's in this movie variable. Again, these do not have to be the same. Okay, if I call this movie, I can call this something else. It doesn't have to be called movie. I could call it, let's say M. Call it M. Okay, it doesn't matter. Okay, what I care about is the actual data. Okay, so I'm passing it in there. Okay. Now in movie component, here, I'm just trying to display. So look, you can see movie is already, we can see that I already extracted it. But we want to see it. So I want to say JSON.stringify props. Okay. Boom, you can see right here. We see it right here. Movie got the inside props. It has a key. You can see this is JSON. One of the key is called movie, and the value is an object which has our movie data. Has a title, has the genre, and also has the year. Cool. So what I could do is I can say props.movie. So now you'll see that here now it says movie, and now instead of the whole thing, I just grabs the movie object right there. Boom. Nice. So now that I know that props.movie contains my movie object, so it has a JSON, JavaScript object with the key title, the key genre, and the key year with its associated values. Cool. So basically what I'm saying is let's create a, let's say a H2, a header tag, and let's put in here props dot was it movie dot title in there. Let's save. Now we see it says Star Wars. Right? Because the movie property came because in app we passed it as movie. That's why. I could have passed this as something else. I could call this data. If I hit save, no longer works because I was expecting it to be called movie, but I changed it to data, so I'm gonna call this data now. And now all is fine in the world. Refresh to get rid of that. Does it make sense? So how you pull it out here must be the same name here. Okay, they must be the same. Okay. Does that make sense? Have I lost anybody? So I will not continue until I get some nods or something that you guys are cool, or you want me to repeat something, or something. Okay. So is everybody cool then? Everybody cool? Yes, good. Okay, good. All right. So I haven't lost anybody yet. All right. Let me know if you're lost. Please stop me. I'll keep going. I assume you know. Okay. All right. So let's continue. So I'm gonna call this movie because to me it makes sense. It makes sense to call it just movie. The property. Remember, at the end of the day, this is just a function. It's a function. Remember, we can send more than one property down this list. We can send more, but we're just gonna send one. Okay. And inside movie, when you say prop, this is just a JavaScript object. It's nothing fancy. It's just a JavaScript object. Okay. Then we can just extract that movie property from this JavaScript object that we created. Remember, this is a property. That's why it's called prop. That's a property. And then we know that the movie has a title. So we're extracting the title, and that's it. I'm gonna refresh this to get rid of that. Cool. So now that I have the title, now I want to display, I don't know. Let's say I want to display the genre in a p tag. Props dot movie dot genre. This is Star Wars, sci-fi. Cool. And let's say I also want to do movie dot year. So now it says sci-fi 1977. So they're both stuck together like that. Okay. So I could add a, let's put it in something else for now. Put in another p tag here. Again, this is not the way you should do it, but just saying. Just so we can practice a little bit. Show that it's separate. Star Wars, sci-fi, 1977. Okay. That's it. So, what if we had multiple movies? Right? What if we had multiple movies? So let me open up the I forgot what it's called. Testing. What if we had all these movies? Okay. So what if we had all these movies? So we had an array of movies. Somehow we got the data. Somehow we got the data from an API, right? You're working on your job. Let's say you're working for Netflix or IMDb, and then you have the list somehow. Somehow you got this data. Now we want to display all of them. How do we do that? Okay. So now instead of just a single movie, now we have multiple movies that we want to render. We want to render them like this. I want to show Star Wars and Frozen, Space Jam. I want to show all of them. So to show that this works, I can say movies. And then remember, it's an array, so I can pick, let's say, the second one. Space Jam. Oh, cool. There it is. So if I start from 0, there's Star Wars. I'm going to copy and paste this. I'm going to put a 1 right here. So that's the next one. So now I have Star Wars and Frozen. You guys see what I'm doing here? You guys see it? Star Wars, Frozen, Space Jam. Do you guys see? Is it clicking yet? What's the green movie for? What's the green movie? This one right here? The capital M? That's our actual function. That's what's called the component, which we created here. Under our components, there's our movie. Right? There's our movie. When we click on that, it's just a function with a capital M. So the way that you execute a function in React is that you use this funky syntax. It looks like XML. And then the way you pass variables into it is you use attributes like this. We call these props. Except that even if you were to submit more than one property or more than one attribute, they all get collected into this one gigantic object called props. And then from there we can extract each individual piece of data that we need to grab. So Galfam's saying that we have an array, which is true. Yes, we have an array. But as you can see, what if we don't know how many movies we're going to have, right? There's no telling how much data we're going to have to process. So we want to be able to do this in a dynamic manner, correct? So how can we do this in a dynamic manner? We have to use a property or one of the methods from an array called map. So we say movies.map. Now, what does map do? So let's bust out the super expensive software, Paint, and let's talk about map. That's a big P. Hold on. There we go. Map. So do you guys remember, your math from let's say pre-cal, right? Pre-cal math. So let's say we had some set with numbers 1, 2, 4, 9, right? We call this a set. So we'll call this, we call this A, but we say that this is our domain. Okay? But let's say this is just our set. Okay? But this is basically our domain. Okay? Then you have another set, right? Let's say, I don't know, 1, 4, 16, 81. And we call this the codomain. Now, the codomain has a very specific meaning. Now, if my, my, what do you call it? The universal, what's it called? The universal set of discourse. Basically, what's the universe that we're dealing with here? If they're numbers, then this is in fact, we can call this a codomain. Actually, no, this is not a codomain. This would not satisfy a codomain because these numbers here, only one shows up. This is not a subset of this, so it cannot be a codomain. So in this case, in my example here, we have a range. Okay. If say we have well, actually no, it can still be called a codomain. Yeah, I'm trying to be too fancy with the math here. Let's just say that my domain is a set of all numbers. So we'll say ... That makes it easier. Okay. So my universal set is the set of all natural numbers. Say, okay, that's my natural numbers. Or is it like this? Hold on. There you go. Natural numbers. Cool. Okay, whatever. So, and hopefully you notice the pattern here. To go from 1 to 1, 2 to 4, 4 to 16, 9 to 18. So the way it happens is that this is our inputs. This is our inputs. We then feed it into something we call a function. So we have a function f. When we give the input, so actually what actually really ends up happening is we have this function f that when we feed these inputs to this function then gives you as an output, let's say this set. Okay. So let's say in this case f, the function f takes some value x and squares it as its output. So the inputs are these numbers, and the function here is just the square, right? Map as in hash map? Kind of. Kind of. That has a that's a very Java language. That's a very Java language. But kind of, but not really. I'm talking about map as in what in mathematics, what we actually call a mapping. So you can say that this function f is mapping these inputs to these outputs. So when you get a 1, you get a 1. When you get a 2, you get a 4. When you get a 4, you get a 16. You get a 9, you get an 81. So there is a mapping between these inputs in this domain and in this codomain, right? So there's more numbers here, whatever. You guys understand a mapping? So this function can literally do anything, right? We can map anything we want. So let's say I had, let's say we had a mapping that looks something like this. Let's say we had boba, and we had a taco. These are our inputs, boba, taco. Let's say what's something a lot of people don't like eating just straight up. Let's say onion. I mean, I like onion, but just play along. Let's say you don't like onions for whatever reason. All right, then we have a function f here. And then in this, we have something that's good, and then something that's bad. So this function is going to map this input, and then it's going to map it to something else. You see how that works? So f maps taco. Oh, taco goes to function f. Function f says that's good. Onion goes into function f. Function f says that's bad, or something like that. Okay. So we have something here that's our domain here is food, and our range here is what we're mapping to is just 2 words. It's the set containing good and bad. Okay, that's it. Okay, let's do another example of map. So suppose we had all of the integers. Okay, let's say we had all the integers. So let's say our set U is all of the integers. So we have like -1, -2, say. Well, let's put this in order. So -2, -1, 0, 1, 2, dot, 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 and then dot, 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 dot. Okay. So these are my inputs. And we have a function f that's going to map to something. And then let's say here, we just had a label, even, odd. So this is the set of, so we can say here that my inputs is the set of the integers, and then this here is the set containing even and odd. What mathematical function can go from numbers to even odd, just like that as a label? There isn't one that's just a mathematical thing, but we can create a mapping to go from one domain to a completely different domain. See, in this case, let's, instead of calling it U, let's just say our set A is this set, and then B is this set, just two labels. Okay, so our set A. Cool. So we say that F takes in a set A, maps it to a set B. We say it maps. So we're taking a set A, we're mapping it to a set B. A and B don't have to be in the same type. These are integers. And then this function maps it to a set that has labels, even and odd. So I can take, let's say 2. 2 goes even, -1 goes odd. I should have a none here, or NA, because 0 is neither even nor odd, right? So I need to add another one. So NA doesn't apply. 1's the only, that's the only one that has it. So odd, and then you see what I mean? You see where I'm getting at? So when you have a function, when you're doing a mapping, you don't even have to be in the same domain. You can go to a completely different thing. So in our case, we're going from like numbers, integers, negatives, 0 and 1, positive ones, or positive numbers, and then we're going to a mapping. We're going to a domain that are labels that only has 3 things: even, odd, and NA, not applicable, right? 0 being the only one that has that mapping. Does that make sense? So the idea here is that we can go from, in computer science world, when we say map, we're taking a set of data from one to the other. So we're taking a set, again, we're taking a set that is made up of some type of data, a data type, and we're going to transform it to another set, right? The result. So if we were to see this result, the result would be, if we have this in order, we should have the result of this infinite array, dot, 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 with -2 being even, comma, and then -1 is odd, comma, and then 0 is NA, and then 1 is odd, and then 2 is even, dot, 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 dot. This infinite array, basically. We have this infinite array, okay? So F produces a mapping to this. This would be the result, okay? Notice that our set first, our inputs, think of this set as just an array. We feed it to a function F that maps it to this. So we have the corresponding -2 becomes even, -1 is odd, 0 is NA, 1 is odd, 2 is even. So the mapping can take us from one domain to the other. That's a mapping. So when you're saying, oh, map as in a hash map, that's where I kind of don't like Java. Some of the naming conventions they use map, I'm like, no. Well, yes, but also no. Like, we're just transforming the data from one to the other. When they say map, they're saying like we're gonna have this one input mapped to some other type of data. So like, let's say you had a string that maps to a number. Okay, technically, yeah, that's technically a mapping. But that's a result of something that has already been mapped. What I want is to transform my data from one space to the other. That can only happen through a mapping. So that's what I mean by mapping. Not necessarily a map, which is what you're talking about, which is what Java, refers to as a hash map. I forget which one's the interface. Their naming convention sucks. They need to add eyes for the interfaces. But what we're talking about is we're going to actually call this map, which is basically a super generic high order function that takes in a function that takes in the input from one domain and returns something transformed, that input transformed to another space. So this map, because it's a method that takes in another function, we say that map is a high order function. So the map is going to take a value. I'm going to call it movie. It's a function. It's a function. Okay? It's just a function. I am then going to map this movie, which is a JavaScript object, I am going to map it to my component. Do you see? I'm going from my JavaScript object to a React component. That's what mapping does. That's what this example was for. It's the fact that you can take something from one space, one data type, and you can map it using some kind of function. We can then map it and transform it to something else. And the result is another set with those results already in there. So if I get an input of an array, like let's say it's 10, then I'm going to get as a result 10 things that have been transformed or mapped to something else. It could be same numbers squared, for example, or numbers turned to strings, or strings turned to numbers, or strings turned to a function even. You can do whatever you want. In this case, I'm going to turn it into a component. So movie, I have my property called movie, I'm going to feed it movie. That's it. So I have to explicitly say return here. I'm going to say return. So look at this. I have an array of objects which has a title, genre, and a year. And if I look at the mapping here, this mapping, you can see it returns an array of JSX element. It's saying that I'm going to return now an array of my transformed input, which is just a movie, into a movie component. So when I hit save here, look at that. I get all of them. Star Wars, Frozen, Space Jam, Hangover, Star Trek, Law Abiding System, and Inception. All in, like, look at how little bit of code I have to write now. So this right here, this little warning says each child in the list should have a unique key. That's because React, the way it knows when a specific component has changed, it needs to have a little unique value whenever you're doing something like this. So what we need to do is, if we grab the index here, we can feed it here. So one of the properties that you don't actually see, but React uses, something called the key. This can be anything. It can be a number, it can be a string, just something that's quote-unquote unique in this scope. So when I hit save, that warning should go away. So if I hit refresh, it goes away. Okay, so just ignore that for now. We'll go over this stuff more. Okay, but let's see what's happening here. Okay, map is a higher order function that is applied to this set. Remember, this is an array. You can think of it as a set. So we have an array. The elements in our set or array are JavaScript objects with these properties: a title, a genre, and a year. We are then taking this data type and we're going to map it to another data type. In this case, we're mapping it to a React component. We're taking a movie and we're converting it into a movie component. Something that looks like this. And now we can generate all of them. So if I were to add something here, like let's say, what's another good movie? Indiana Jones. Genre, action, and adventure. When did this come out? It was like 1980, something like that. We'll say 1980, whatever. Hit save. Boom, look at that, Indiana Jones, there it popped up. See, I don't have to do it one at a time. And then if this ever changes, more gets added, some get removed, it doesn't matter. This thing will handle it for me. All of it. Look at that, how clean that looks. Okay. Does that make sense? Are we okay? Time is it? 7:24. Got 6 minutes. If you guys have questions, I'm sure this probably was a little heavy. You're okay? You guys are okay with this? This makes sense? Complete sense? You guys are okay? Remember, this is just a lot of this, honestly, like when you're confused about some of this stuff, just refer to the mathematics. A lot of this just deals with math. It does. It seems really specialized. Is there a for loop equivalent that can do the same but less fancy? Is there a for loop that can do the equivalent but less fancy? Yes. Yes, there is. Why is a hash map necessary again? This is not a hash map. So it's good that Jim asked that question. So let's do this. Watch. Const. I'm gonna call this React movie components is equal to. I'm gonna extract this. Paste it in here. Okay, I'm gonna inject here. We'll do that here. If we hover over this, if we hover over React movie components based off this mapping, this is an array. It's not a hash map. It's an array. It's just an array. So this is not a hash map. So if you're in the Java world and hash maps and stuff like that, this is not a hash map. This is an array. So the movies array has a certain length, let's say 10. Map will not change that. You will get back an array of 10 things. What those things are depends on what you return. That's it. That's why I say we're converting one set to a different set. But the sets are the same length. Has nothing to do with the hash map. Okay? It's just an array. And here I can just say React movie components, just stick it in there and boom. Because this is just an array. You can see that? It's an array, but these are JSX elements. It's React's type for these types of components. That's what they're called. It's not a hash map. It's an array. So I can actually compare the lengths. I say console.log movies.length. Okay, so we can display the length of the movies. And then console.log React movie components.length. It's just an array. And they're both 8. Mapping does not change the size of your set. It's going to take one set, whatever size that is, map it to another set of the same size. The data could be different. It depends on what you do. The function that we create, remember, this is a function, guys. Remember, that's a function. This is your transformation function. You define what you want to do, how you want to do this. Okay, do we have enough time? We have 3 minutes. Okay. Let's go back here. So remember how we were sorting? When we were sorting, we had all these movies? Not too bad, right? Now, let's imagine for a second that your boss, for whatever reason, said, hey, I just want the titles of the movies. I don't want the whole enchilada. Just give me the movie titles, but I want them sorted. Like, okay. So there's a couple things you can do. Let's say that you already sorted the movies. So you already did this, right? So we can just, let's console log this real quick. Console, let's run this. Okay, so we can see again. Okay, so this is an array of JavaScript objects. And it has our movies here. Remember, this is a JavaScript object, comma, another JavaScript object, comma. Remember, this is an array because you have the square brackets. Okay, and the JavaScript object has these key value pairs. It has these properties, title, genre, year, with the associated values. Okay, then your boss says, okay, we don't want the whole thing. I just want the titles. You're like, okay, so how do you do that? Well, instead of creating, the naive solution to that would be something what Jim was saying. Is there a way to do this without the fancy loop thingy? Can we just do a for loop? Yes. So this would be one way, which is totally valid. We say const, and we'll call this titles is equal to an empty array. We can then loop through using a basic for loop. Why not? Movies.length. Whoops. Okay. And then this is applicable to like any language, right? Your Java, whatever. Then we just say titles.push. This is how you add things to an array. Push, and we say movies at I dot title. Okay, so I'm going to log my movies, and then I'm going to log the titles. See, there we go. See that? We have the movies, and then we have just the titles, right? And we went about this in a really roundabout way. Is this wrong? No, it's not wrong. However, what's the problem here? The problem is this. Too much details. Too much details. We want to abstract this. I don't want to know that I'm using an array or a for loop. What if we wanted to use a for each loop? Or what if we wanted to use a for of loop, right? Some kind of iterator. Those kinds of details need to be moved away from here. This, too much detail. We need to abstract. So how can we abstract? Well, if what we can do is we can use a mapping, which does the exact same thing. Notice that if you think about it, this is our set, a set of elements whose elements are just the type of JavaScript object. And you can say that we technically mapped. What was our function? Well, we didn't have a real function. Technically, this was the function, but we're going to use that term loosely. The code here, it was trying to act as a function and basically mapped this to this. Notice that this is why I'm saying this has nothing to do with hash maps. Mapping in the mathematical sense is taking one set of the same of one size and then converting it to another set of the same size, but a transformation has been applied to those inputs. So when you have an output, you have an output of the same size, but the inputs have been transformed in some way. Let's say you squared the numbers, or you took the square root of them or something. I don't know, whatever you want. In this case, our mapping function, quote unquote, took the JavaScript objects and just extracted out the titles. So, can we do this in a better, more elegant way so we can abstract the details of how this was accomplished? And the answer is yes, through a higher order function called map. So we say movies.map. Feed it the transformation function. Call this movie. And then all we want to return is, you can return something. Return movie.title. Clear the board. Run this again. Same output. I have my movies. This is my set. And I have now my new set of the same size with the titles extracted out. Let's say your boss says, oh, we actually just want the years. Okay. There you go. Oops. There you go. Now you have the years. Oh, we want just the genres. Okay. There you go. I don't have to do a whole lot. The details of how this is accomplished is abstracted away. That's the purpose of these higher order functions. So Jim's saying, so if you were to use that for loop in React, where would it go? I'm just trying to get my footing. Sure. So how would we do this in React if we wanted to do it that way? Sure, no problem. So we can say something like, we'll call this result. Or what do you want to call it, Jim? Oh, we'll call it Jim. So the answer here is Jim. So Jim is equal to an empty array for now. We're going to go through a for loop. For let I equal to 0. We need to iterate over our movies. Plus I. Okay. Okay. Now, for legibility's sake, let's just create a temporary scoped variable. We'll call it const movie, the current movie. Or we can call it current movie. Or we'll call it Bob, Jim Bob. Okay? So we have Jim, now we have Bob. Bob is what? Bob is movies at some index. We'll call that index I, right? Some element. That's Bob. Okay. Now I'm going to say Jim.push. And here's the crazy part. What am I going to push? I'm going to push the React component called movie. What is the property that movie is expecting? It's expecting a property called movie. I know that part probably confusing. Movie. But movie here, this capital M refers to the function, the component name, movie. This movie is the property that we're expecting to exist. We're going to push this, the creation of this component, we're pushing it into this array, this Jim array. Now I'm going to pass Bob because that's where my data lies. And it's a self-closing tag, so you do / and close it off. Okay. Now it's going to complain because it's like, hey, when you do this, you should probably give it a key. So I'm going to give it a key. Key of I. Okay. This is the enchilada right here. Movie and this part right here. The key part, that's just React, so it doesn't complain. I don't want to hear it complain. Now I can just say, okay, hey React, can you render Jim this array that contains a bunch of React components? And then React's just going to say, why yes, hit save, and there we go. Done. This is the roundabout way of doing it, but look how messy, right? Look, there's too much details. Too much details, right? Is this the most optimal way of doing it? I don't know. Maybe, maybe not. But there's some developers that, the browser developers that created that map and have an implementation that's probably faster than what we just did right now. Maybe it's the same. I don't know. But they have a higher order function and they abstracted those details. See, I don't know if they use an array. I really can't tell you. I don't know. I'm not a browser developer. I'm not a browser engineer. You could probably look it up. What's the implementation behind this? Chromium is open source. Why don't you go look it up? Maybe they use a for loop. Maybe they use an iterator pattern. Maybe they're using a map. I don't know. But those kinds of details is supposed to be abstracted away. Jim says, I appreciate the abstraction too, but for my first go at React, seeing the naive way is helpful. Yes, okay, so hopefully that makes sense, right? Hopefully that makes sense. And just like our example here, right here, how we had it before with the for loop and stuff, that's probably a way that most people would solve this problem. Like if they're, I deleted it already. How people will solve that problem, right? Let's create an array, let's loop through it, and then let's add the elements to the array as we go through. Yes, that's totally valid. That is the solution. But sometimes these details, we need to just let's get away from the details. Let's abstract these things away, and that's what the higher order functions give us. They give us that ability. Higher order functions are not unique to JavaScript. Higher order functions exist also in C#. In the form of the link library, you can use that. You can do other stuff too. Python, I can't really speak for Python, but maybe Python has a higher order function. I would presume probably Python has something like that. Yes, this is my first time really abstracting, and it is faster for sure. Well, remember, we can't say it's faster. It's less coding, and the details we're abstracting the details away. Sometimes using map like this is actually slower. Okay? However, for example, when would it be slower to do this versus some other way? When the amount of, data that you're actually trying to map from one to the other is very low. This is probably, it's technically slower because you're calling this function on an input, right? Remember, you're still wasting a function call. I mean faster, so it's all. Yeah. No, but this is a true argument. That this really isn't a real argument, which is why a lot of the answer to a lot of these things is it depends. In some situations, map can be slower if the data that you're using is not that complex, and doing a function call is actually more overhead than if you had just transformed the data yourself in a for loop. However, in some systems, when you're working specifically with backend, doing a mapping can actually boost performance in your server architecture because map has been optimized to use, bare metal calls. So that's why I mean, like, these kinds of argument, like, it depends. Is it, I would say, is it more legible doing something like this? I would argue that yes, this is more legible because it's mathematical. Yeah. But again, talking about optimization, we will talk about optimizations, but when you're first building your projects and stuff like that, optimization is probably not something you should think about. You should think about optimizations once you have something built, and then you optimize as you go, which we will talk about when we talk about something called memoization, how we can create a cache so our components don't have to redraw. So, okay, so I think so. Again, in this session, I just wanted to go over one, introducing some more complex ideas of higher order functions that we can use, like map. Again, you can totally do this. We just saw you can totally do this. But if you ever look at documentation of people showing you example codes, they're always going to use a map somewhere because it's just like it makes sense. You're taking one input and you're mapping it to a React component. It makes sense, right? When you use the map, the idea of what map does as a function, like at least in mathematics, it makes sense. You're transforming from one data to the other. It's a transformation, basically. It makes sense, right? Because you're usually always going to have an array of data that's coming from a backend. Because remember, React is what? Your front end for your website. So the data doesn't live on your website, it lives outside in some server. So we're constantly going to be grabbing data. That data, though, is not good enough to just display to the screen, so we have to transform it in some way. That's usually done through some kind of mapping, especially if the data is contiguous, right? We have like an array. They're right next to each other, so you might as well just do a mapping on it. That makes sense. Okay. And then again, more examples of props. Here's movie, passing data from app.js to my component here called movie. And then it has the responsibility of how to draw it. Okay. Notice that movie has no indication that this is part of an array. Separation of concerns. There's no spaghetti code here. This component is what we sometimes refer to as a dummy component. It has no real logic. It just displays stuff. App has a lot of business logic. In fact, I would argue it has too much business logic. So we'll be abstracting this over the coming sessions. Okay, so still haven't gotten a chance to talk about state, but we will talk about state on Friday. Okay, hopefully that props make sense, how we can send data to a component and then have the component do its logic to draw. So movie here is just drawing with divs and whatever, right? It's just drawing title, genre, year. Mapping is just taking the data, just pretend that we got this from a backend, and then we're just transforming that backend data to something that we can use with React. That is, we want to use these components. So we're going to do a mapping. This is an example of a mapping, a roundabout way, but still a mapping. And then we're just going to tell React, hey, can you draw this array? React knows how to draw an array of JSX elements. It knows how to do that. Okay? If it didn't know how to do that, we would have to solve this problem in a different way. But because React knows how to draw arrays of JSX elements, we can just feed it an array like that. This is just an array. Gym is an array. And we're feeding it to React, saying, hey, can you draw this? And React's like, yes. And that's it. And that's it. So if anybody has any questions, feel free to ask. And oh, I hear Stitch here. Sorry for not related question. Anyone here is taking CS152 Corvettes? I have some questions. Let's ask. Yeah, some cryptography questions. Yeah, sure. If you want to ask, go ahead and ask it in the Discord chat. And I can probably answer that question. I took his class, so by all means. Okay, cool. So with that, I will let you guys go. I'll see you guys on Friday, and I would say that the only thing I would say as an exercise is try to recreate this exact same thing. Either watch the video again. I would say try to do as much as you can from memory, and then watch the video, and then try to do it again. Okay? All right. See you, everybody. See you on Friday. Bye.